Good afternoon. My name's Charles Palin, and I'm a senior at Central Michigan University. And what we're doing today is we're going to test an autonomous robot navigation application that I've developed for my senior project. Let's take a look at the items that are included in this experiment. So what we're doing right here is we're actually taking a measurement of this spot over here, and what we're going to do is try and drive the robot by itself from the point where the cameraman's standing over there to this point right here. Now what we're going to do is I've got two different navigation algorithms that I've wrote, and the first one is the more primitive, and then the second test we do will be the more advanced algorithm. Now, this is all heavily dependent on whether or not we constantly get a GPS signal throughout this process. So we'll see weird things happening to the bot if the GPS signal cuts out. So what we're doing right now is we're doing the first run with the primitive algorithm. So let's take a look. Okay, a problem with this is that this cord is too heavy in order to for the robot to actually run. Oh, come on. Another thing that may be happening is the robot may think robot seems to be getting stuck on the surface that we're going on here. And currently we're going in the exact opposite direction that we're supposed to be going on. So we're still going away from the actual target. And one of the major problems with this is this dragage, as well as we don't have a compass. Okay, we're just pretty much going to scrap this one. So now let's try the advanced algorithm and we'll see what happens this time. So here we go. Now what the bot can do with this algorithm is it can actually pick which way it thinks it needs to go, or what speeds it thinks it needs for the wheels. One of the main problems we're seeing here is it's getting hung up on the cement. But in all reality, you can still see that this is much better than the last one. Now, as you can see, the actual place we're trying to get to is right here, and we're kind of just going around in a loop around it. Which it said that civilian GPS at its best can only get accurate to about 3 meters. So, I mean, we're getting pretty darn close for civilian GPS. Now we're actually going to stop the experiment right here. Okay, so as we've seen, the second run was obviously better than the first run. And in the first run, right now I'm standing where the bot started both runs. In the first run, we ended up about over here, which is completely opposite of where we were trying to go. But in the second run, we ended up actually way over here, only about less than 5 feet from our actual final target. So now there's some important things to remember. The only thing we're using here is GPS, and we're using GPS as a compass, and we're using it for navigation. So if the GPS fails, our robot's driving in the dark. So you can see that just with code, we were able to get about 3 to 5 feet from our final target. And something to mention too is the GPS unit we're using, the Jarman GPS 15L, can be picked up for about $75. Then the antenna we're using is about $25. And the K-Team Hemisson robot runs around $255. And this experiment probably would have worked a lot better. It still turned out very good, but it would have worked a lot better if we would have had a compass, maybe bigger wheels so it wasn't dragging so much on the ground, and I think we would have seen better results. So feel free to download the code and give it a try for yourself.